Okay, this problem covers identifying parallel and perpendicular lines from equations. Okay, first things first. Parallel and perpendicular lines have to do with the slope of a line. And the slope is simply how it's slanted. So if I had two lines that run side by side and never ever touch each other, those are parallel lines, okay? And parallel lines have the exact same slope. They're slanted exactly the same way. But perpendicular lines, if you have two lines that intersect each other, but they have to intersect at a perfect T, or what they call a perfect 90-degree angle, that is perpendicular, okay? Now, perpendicular lines, they have opposite and reciprocal slopes. And what I mean by that is, let's say one line, let's say the green line has a slope of 2/3, which means for every 2 units you go up, 1, 2, you have to go over 1, 2, 3, and you find another point in the line. Perpendicular would be opposite, meaning if the green line is a positive slope, then the perpendicular line, which is in purple, would have to be a negative. That's what I mean by opposite. They're opposite signs. And then reciprocal is just like the word reciprocal from fractions. You just flip it over. So 2/3 becomes 3/2. So that's an example of perpendicular. Now, lines can crisscross lots of ways. Like you can have a line like this, and you can have another line like that, and they cross right here, but that's not a 90-degree angle. That's a tall, skinny X. Or you can have a short, fat X like this, whichever way you look at it. That would fall under the neither category. If they're the same slope, like let's say this one has a slope of 3/4, then the blue one would also have a slope of 3/4. They have the exact same slope. Perpendicular, they have to be opposite in sign and reciprocals. And if they're not the same or they're not opposite reciprocals, they fall under neither. Okay, so that explains that part. How do you take these 3 equations though and figure that out? I'm actually going to start with line number 2, because line number 2 is already in the what they call the slope-intercept form of a line. When you have an equation, solve for y, and it's equal to some number x, and then plus or minus some other number, they call it the y equals mx plus b form, where the m, whatever number is right here, that is your slope. The b is actually called the y-intercept, but for this particular problem, we don't care what that is. They're only asking me about parallel and perpendicular lines, and that is all about the slope. So I need to figure out the slope of all 3 lines. And line number 2 is already solved for y, so I can already see whatever number is in front of that x, that's your slope. So the slope right here is negative 5/3. The slope on this one is negative 5/3. Now, in order to do line number, where are our colors here? Line number 1, I have to solve that for y. So follow me down here, over here, front and room. It's close to being solved for y, except the y has a coefficient on it. I need to get rid of that -5. So to solve for y, I'm going to divide by -5. That cancels that off. But what you do to one side, you got to do to the other. And since the other side has 2 different terms, they both have to get divided by -5. So what I'm ending up with here is y equals a +3 divided by a -5. A positive divided by a negative is a negative. And since 5 doesn't go into 3, I'm going to leave it as -3/5 x. And then this is -2/5. But what I need to know is this guy right here. The slope on equation number 1 is -3/5. Now, line 1 and line 2 have reciprocal slopes, but they're not opposites. So line 1 and line 2, which is what they're talking about right here, line 1 and line 2, they're not parallel because they're not the same. They're not perpendicular because they have to be both opposite and reciprocal. It's got to be both. It's the reciprocal part, but they're not opposites. So this one's a neither. And it's still going to mess with line 3. So line 3 is going to take a little bit more work to solve that one for y. I could get room over here. Follow me. All right, so we got 6x minus 10y equals 8. Now I'm trying to solve for y, so the first thing I'm going to do is subtract that 6x. Come on, 10, what you doing? There we go. So that cancels out. Boop. That leaves me with -10y on the left. Now, I'm going to put it in what they call the mx plus b form. It's actually the slope-intercept form. So instead of 8 minus 6x, I'm going to put the minus 6x first. And then since the 8's a positive, I'll put a plus 8 right there. I just like to have it in this form. And then I'm going to divide off the -10. But everybody's got to get divided by -10. All right. So those cancel. I'm just left with y. A negative divided by a negative is a positive. And 6/10 can be reduced down to 3/5 x. And it really doesn't matter what this is. I don't even have to finish doing this because all I'm interested in is this guy right here. The slope here is positive 3/5. Okay, so we're now comparing lines 1 and 2. Let me go back here. Line 1 was my purple one, and I'm comparing that with line 2, which I did in pink. So purple and pink, they're reciprocals but not opposites, so that's a neither. Line 1, that's my purple one, with line 3, which is my green one, they are opposite. They're opposite signs, but they're not reciprocals. Oh, for good God. That's also a neither. And then line 2, which is my pink one, I'm comparing that with line 3, which is my green one. And, wait, pink and green, okay. They are opposite signs and they're reciprocals, so that one's a perpendicular. I wish they'd given me one that was parallel. The closest that was parallel was the purple and the green. They're the same slope numerically, but opposite signs. So if this had been a positive, then I would have said lines 1 and 3 are parallel. But because they're opposite signs, that's a neither. So I hope that explains that. I don't know what you're going to get generated. More than likely at some point they'll give you two of these that, you know, have the exact same slope, and then you'd say parallel. All right.